We spent all the time factoring, and now we're going to see one of the reasons that we factor by using the zero product property. Now, the zero product property says if I multiply two numbers together and I get an answer of 0, then one of those numbers or one of those variables has to be 0. So if I do a times b, my answer is 0, then either a or b or both of them have to be 0. We use the zero product property in quadratics to tell us where the root of the parabola is. The parabola is a graph. As you see it right here, it looks like an N. It can also be the other way. We'll get more into that later on in the year. But the zero product property tells us where the roots of that equation are, or in other words, where the graph crosses the x-axis. So on this graph, it crosses the x-axis at 0 and 8. So that means the roots of that quadratic would be 0 and 8. And that's what we're going to use the zero product property to find. To find the roots of a quadratic, or where the graph crosses the x-axis, first you need to factor every quadratic completely, just like we did the past several weeks. 2 terms, difference of squares, 3 terms, first times last, find out your factors, make your binomials, or if you have 4 terms, do it by grouping. After we get our binomials, we need to separate them into 2 equations. Once we have them separated, we're going to set them equal to 0 and then solve for x. Right, whatever that answer is, that is the root, or where the graph crosses the x-axis. Right, so first thing I'm going to do is show you how to solve for x. So let's say I had a problem and I completely factored down to x plus 5 and x minus 3. So what I'd want to do is separate it into 2 problems. X plus 5 equals 0 and x minus 3 equals 0. So we're trying to find numbers that we would plug into these binomials to make that when I multiply them I would get 0. So I want the opposite of the number that is in the binomial now. So to solve for x, I want to subtract 5 from both sides and do 0 minus 5, which would give me negative 5. And then on the second binomial, I'd want to add 3 to both sides, and that would give me x equals 3. So if I plugged in negative 5 and for x, or if I plugged in 3 into x, and I simplified it, I would get an answer of 0. Right? When you have a GCF, this would have been a problem where we had a GCF that we took out first, and then we factored down to get the 2 binomials. You have to, however many x's there are, you have to set all of them equal to 0. Right, so I have an x on the outside, you just set it straight equal to 0. And then I have an x minus 2, set that equation equal to 0. Then you have an x plus 1, set that equal to 0. Right, for this first one, x equals 0, it's already solved for, it's already completely done, you're finished with it. For x minus 2, you'd want to add 2 to both sides, 0 plus 2 is 2. For x plus 1 equals 0, you're going to subtract 1 from both sides, x would equal negative 1. So what these answers tell me is that if I plug in 0 into all these x's, or if I plug in 2 to all these x's, or if I plug in negative 1 to all these x's, and I simplified it, I would get an answer of 0, which is what I want. Okay, so on this problem, we want to factor and find the roots, so we're going to go through all of our steps now. So we're going to have to do, this is 3 terms, so we're going to do first times last. So 1 times negative 8 is negative 8. Factors of 8 are 1 and 8, 2 and 4. This sign is negative, so that means I want my bigger number to be negative, and I want it to equal negative 2. So I want 2 and negative 4. 1 over 2, 1 over negative 4 are fractions. We cannot reduce either one of them. So we have 1x plus 2, and 1x minus 4. Alright, so now we have factored it completely. Alright, we have our two binomials. Now we need to solve them like we did the previous examples. So we're going to break them into two problems. X plus 2 equals 0, and x minus 4 is equal to 0. And solve for x. So here I would subtract 2, and x would equal negative 2. Here I would add 4, and x would equal 4. So the roots of that quadratic would be negative 2 and 4. So if I graphed it, it would cross the x-axis at negative 2 and 4. Right, for this next one, you want to look for a GCF first. Always look for your GCF. We have x squared and x, so x's are in both terms. So we're going to factor out an x. I had two x's. I took out one x. That means I have one left. I have one x here. I took it on the outside, so I don't have any x's, but I still have that minus 10. Right. So the only other thing we could check to do is look at this inside, see if we can factor it. Neither one of them are a perfect square. There's two terms, neither one of them are a perfect square, so we can't factor it. So we just need to set everything equal to 0 now. So we want to set our x equal to 0, and our x minus 10 equal to 0. X equals 0 is already done and solved for, so it's finished. And then for x minus 10, we would just want to add 10 to both sides and get positive 10. Okay, our next example, we're going to do first times last. 2 times 12 would be 24. Factors of 24 would be 1 and 24, 2 and 12, 3 and 8, 4 and 6. Right, they're all positive, so we were going to want 3 and 8. So we have 2 over 3, and we have 2 over 8. 2 over 8 will reduce to 1 over 4. Set up our binomials. We'd have 2x plus 3, and we'd have 1x plus 4. Alright, now we have our two binomials. We need to separate them, set them equal to 0. So 2x plus 3 would equal 0, and x plus 4 would equal 0. Now this first binomial here, 2x plus 3 equals 0, we're going to have to do a two-step equation. So to do that, you always want to move your constant first, or the number without the variable. So we're going to want to subtract 3. So we have 2x is equal to negative 3, and divide by 2. The 2's would cancel, which would give me x. Negative 3 divided by 2, if you divide it, it comes out to be a decimal, so you just leave it as a fraction, negative 3 over 2. Then for the second problem, I'm going to subtract 4 first. 4's cancel, give me x equals negative 4. So my roots of this quadratic would be negative 3 halves and negative 4. Okay, our next problem, GCF, I can divide all three terms by 2, and I can factor out an x. So 2 divided by 2 is 1. I have 3 x's, I take out 1, that leaves me with 2. Negative 12 divided by 2 is negative 6. I have 2 x's, I take out 1, that means I have 1 left. Negative 14 divided by 2 is negative 7. I had 1 x, I took it out, I don't have any left. And then I need to factor the inside. So I want to do 1 times negative 7 is negative 7. Factors of negative 7 are 1 and 7. Since this sign is minus, that means I want my bigger number to be negative. So I have 1 over 1, 1 over negative 7. Leave the 2x on the outside, gives me x plus 1 and x minus 7. Once again, I have 3 x's, so I need to set all 3 of them equal to 0. So 2x equals 0, x plus 1 equals 0, x minus 7 equals 0. Then to solve for x on all 3 of them, the first one you want to divide both sides by 2. 2's cancel with 0 divided by 2 is 0. The next one I'm subtracting 1, so x would equal negative 1. The next one I'm adding 7, so x would equal positive 7. Go ahead and pause and do the first you try. Alright, so first thing you need to do is factor. So you were doing first times last. 8 times negative 7 is negative 56. Factors that we're going to use are 7 and 8. Since this x is positive, that means we want our bigger numbers to be positive. So negative goes with the 7. So we'd have 8 over 7, 8 over negative 7, and 8 over 8, which reduces to 1 over 1. Our binomials would be 8x minus 7 and x plus 1. Separate them and set them equal to 0. So 8x minus 7 equals 0, x plus 1 equals 0. And then to solve, once again we have a two-step equation. Move your constant first. The constant is the number by itself, so add 7 to both sides. Gives me 8x is equal to 7. Divide both sides by 8. X would equal 7 over 8. And then the second one, you just need to subtract 1 both sides to give you x is equal to negative 1. So 7/8 and negative 1 are the roots of the quadratic. They're where the graph crosses the x-axis. Go ahead and pause and do the final you try. So once again, do first times last. 4 times 1 is 4. Factors are 1 and 4, 2 and 2. Everything's positive, so we want the 2's. We would have 4 over 2 and 4 over 2, and they both reduce to 2 over 1, which would give me 2x plus 1 and 2x plus 1 is equal to 0. Separate them and set them equal to 0. Subtract 1 both sides. Give me 2x is equal to negative 1 divided by 2. X would equal negative 1/2. This is the exact same. These two equations are the exact same, so you're going to get the same answer. X equals negative 1/2, which means this graph would only touch the x-axis at negative 1/2. So to find the root of the quadratic, you want to factor completely, separate your binomials, set them equal to 0, and solve for x.